In this video, I'm going to show you how to create the tiling grid for processing the LiDAR. This Delaware area that I'm working on is not that big. In theory, I probably could have loaded in all these 1 million points at once, just load in all the LAS files and then I would still need to create the footprints because we would only want it to grid to that data, otherwise it's going to take longer to grid. But for the bigger areas, the reason why we do it this way with the catalogs is to not pull in all the data at once, but rather pull in the data in a certain sequence. And this tiling grid that I'm going to show you how to do will enable us to, when everything's said and done, as this is gridding, it will pull in, map catalog will pull in this file, grid the tile, etc., etc. And it will also grid, perfectly square tiles. That's why it's important to make sure that your projection is set up properly, which should be your final, whatever your final deliverable is in creating these clipping grids. So I'm going to go ahead and load in the 2 footprints that we created. This is the footprint of the LAS extents. And it looks like I'm turned that one off. Okay. So with the Delaware, the 100-meter buffer one on, because this is going to be the largest, this is what you're going to be ultimately clipping to in the end, is this 100-meter buffer. The AOI, the delivered AOI is smaller, but again, we do a buffer just so we have some extra, make sure that we don't have any gaps. So the first thing you want to do is make sure you have the 100-meter buffer loaded in, and the tools moved on me, so okay, my tools were hidden over here. So there's a tool here, the create grid, and I'm not sure where it's at here. I don't know which toolbar it is, but it's this create grid in Global Mapper, and you could do the same in ET GeoWizards if you want, but I do it in Global Mapper because it's just as easy. So what I do is I'll choose create grid and just pick a point with this 100-meter buffer on, because that's the largest extent that we will be gridding to. And I create a grid of 1,800 meters by 1,800 meters. It's just something I came up with. You can test different. This is just what worked for me. And then choose this calculate grid counts to fill rectangle, hit OK, and what that will do is that will essentially make an 1,800 meter by 1,800 meter grid within this entire extent of the 100 meter data. So now we have 1,800 meter tiles. So when everything's said and done, the way this will work is when you process the LiDAR, it will come in here and process A1, load in the data, zoom into A1, load in the data, zoom into A2, load in the data if necessary. It may have already loaded in some of the data. So that's why these numbers it's kind of important too that the numbers are in somewhat of a sequential order, coming just like how it is here. And the default just labels it this way or assigns the attribute this way. So I need to export out this grid. And I put these in temp files usually, and I just call it something like. And then I'm going to close this, open up that file I just created. And the reason why, and then I'm gonna create a buffer of these at 100. A buffer of these at 40 meter. spacing of each of these, and that will actually be the tile with a little 40-meter buffer. And so I'm going to go ahead and pull in the 1800-meter grid. And the reason why I'm doing this, where I unloaded that one the grid that I generated, loaded in the 18-meter that I export, because there's a bug in Global Mapper. If I create the buffer and export that out, it messes up the order of the object order, and it's important that the object order stays intact, and I'll show you that later in ARC. But so select all the files, and you want to create a buffer, and I do it at 40 meters. So I want a 40-meter buffer, all these settings here. Create rectangular buffer, make sure that's checked on. And put this in a layer called buffers. And now we have a 40-meter buffer of that 1800-meter grid. So what it will do is when we get to the part of processing LiDAR, it will basically select this. It will load in all the tiles in the catalog for here, all the LAS files, and then move to this one. And some of the files will already be loaded because of this, and then it's just based off of the catalog view of how many, the settings here of how many. This is just my default, but if you've played with these defaults or these settings, you know, it could theoretically load in more LAS tiles at once and process bigger areas, but this has always worked for me just doing it this way. So it will grid and give you this 40-meter buffer. And what's nice about having a buffer after everything's gridded is that in Global Mapper you can load in all the tiles and then just tell it to clip it by like 10 meter. And so since you have a 40-meter on buffer on each side, if it clips each one of these by 10 pixels or 10 meters, if it's 1 meter data, then it will ensure you that you don't have that crazy interpolation or seams between adjacent tiles. That's why I don't process the LAS tiles individually. I put them in a catalog, because otherwise you get, along the edges, you get those interpolation anomalies. And by gridding the data with a buffer, and then simply, once the data is gridded, and I'll show this in another video, by adding that 10 pixel crop, it ensures you don't have those anomalies along the edges, but it also allows you to tile or grid the data in manageable pieces. That's what we're doing. We're gridding the data in manageable pieces instead of trying to throw all the data at the system at one time. So now that I have the buffers done, I'll export that. And I just call these buffers. And then in ARC, what I would do is load in the buffers. The 1800-meter grid is junk now. We don't need it anymore, really. The buffers is what we're going to grid it to. And these have the overlap. So now what we want to do is clip this to this. So the next thing we want to do is we want to load in the footprints. So for the LAS here, the footprint, since we already have more coverage in this, the footprint will be, I'll create that. The footprint will basically be the extent of the 100-meter buffer. That's what we're going to clip to. We're not going to process all this outside data. There's no need to. So the first one I'll do is for the 2014. And if you have just one vintage that covers the entire AOI, I want to create a grid that clips it by these tiling buffer systems, but we don't need to do the entire data set. We just need to do within the extent of that buffer. So we need to clip the buffers to the 100-meter data set. So buffers clip to the 100-meter because we don't need anything outside of this 100-meter boundary. And just put in the temp for now, because sometimes the sort order would be wrong. Then this looks right, but this is very, very important here. So first thing you'll know if something was messed up, it will clip it right. But the important thing here is making sure that these are in order, because you don't want the data to, here's what you don't want to happen. You don't want in Global Mapper you have the index on, and it comes in here and grids A1 first, and then, since the polygons are out of order because it's gonna go by polygon sort order, you don't want it to go to this polygon first and then this polygon here and this polygon here, because it'll be inefficient. It will load in this data, then it'll come and load this data, and then this data, and then come back to this data. Whereas if it's in sequence, it will load in the data here, move on to the next one, and it's possible that the data is already loaded in from processing this first tile. So it's a much more efficient process if these are in order. So in ARC, to make sure they're in order, just make sure that if you look at the FID, and the FID will be in sequence, right? That the names are also in sequence, A1, A2, A1. You don't want these all scrambled. If they become scrambled, you would sort it by the name. So if I wouldn't have, I'll show you how that works. So I have the buff, so if I would have created the 1800-meter grid, and without exporting this, I export this as the shapefile 1800 meter. If I just would have in Global Mapper did the buffers next. And we're gonna make sure we put this on the buffers layer. Now if I would export this out, call this buffers 2. I wouldn't be going over this if this wasn't important. Looks like this came out sorted right, but I kind of want to mess up the sort order so that you need to realize that it needs to be sorted by name. These objects they need to be in order. All these are basically in order, but I've had it come in where these are not in order. And when you check the table, it'll go A1, G2, C1, whatever, all out of order. These have to be in order. They must be in order. I can't stress how important that is, because that's what creates the efficiency, is being able to process this in sequence as it's loading the data in. So it's critical that these shapes are in order. So off of this, I'm just going to export this data out now. It is in order. We checked that already. And I'm going to put this, no, let's go here. So we're going to call this one, I always call this step 1. Just so it's easy to find. Generate DTM, DSM, grid. Generate, and I'll usually put the vintage of the one. So this will be what we'll use to generate the 2014 grid. And then I need to do the same for the 2017 because it has a different footprint, and we only want it to clip to the extent of the LAS. So I don't want to use the same index that I just created for 2014. 2014 has full coverage, so we can take that buffer file and do it to the full extent of the 100 meter AOI. This case, however, we don't want it to process out here because this is all no data, and it will make the gridding time take longer because it's going to try to grid all outside in here, and we don't need it to do that. We only need it to grid wherever the extent is, or the clip is, to the extent of the LiDAR. So we need to clip this one as well. So, but this one, first what we need to do is clip the footprint to the buffer. And sometimes I'm not organizing this well. So usually what I'll do is create a folder called footprints, and then put everything in there. But right now we'll just do it this way, and we'll call this one could actually call this one 2017 LAS footprint. So this is actually really going to be the final footprint because this is actually really the final footprint that I would send because it's clipped to that boundary. So let's see, let's see if we can get those. Okay, so I want to pull the buffers back in, and I'm going to clip, again, I'm going to do the same thing just to show you what's. So again, I'm going to do the same thing here. Now that I have the LAS footprint, that I download it, clip to the 100 meter buffer because that's all I need to grid to. I want to create a similar gridding index that I did for 2014, but this time it's going to be for just a 2017, so it will be the clip of this. And our input features where we want to clip the buffers to the final footprint we just created. And I'm going to put this in a temp geodatabase in case the comes all messed up, out of sorts. Yeah, it came in, it looks like it's sorted properly too, but I'm going to open up the attribute table and make sure that the sort order is right, and it's sorted right, needs to be sorted by name. Those need to be in order. That's how the objects need to be. So if they weren't in order, what you would do is sort the shapes using ET GeoWizards. You would sort the shapes by the name in ascending order. That way the name is in order and the object ID is in order. That's the way it's going to process in order of the objects. So you need to make sure the name is the same as the order of the objects. So let's see what we have here. So this is the result of the clip with the final footprint for 2017. So I'm going to export this out as And this one will be 2017. So we're going to generate 2014, and this one we'll use to the 2017. And just make sure that everything looks right, and that's basically it. In the next video, I'll show you how to grid the LiDAR using these gridding tiles that I just created.